Let's go over this practice test then. Number 1. Now, a sequence converges or diverges depending on whether the nth term has a limit or not. It's that simple with a sequence. So in the first one, the nth term is n over 2n plus 1. The limit, as n goes to infinity, of n over 2n plus 1 is 1/2. The limit exists. And that's all you need for that sequence to converge. The sequence converges to 1/2. Okay? That converges to 1/2. And I believe on the test, on these, I think the answers are converges to 1, converges to 1/2, converges to 1/4, and then diverges. Yes. So the answer would be converges to 1/2. Now, if this were a series and we were adding up an infinite number of those terms, the series would diverge because those nth terms are not going to 0, they're going to 1/2. And if you add up an infinite number of 1/2s, guess what? That's going to go to infinity. Okay? So the series would diverge if you were adding up those terms. But the sequence converges because it merely needs to have a limit as n goes to infinity. Any limit will do. All right? Number 2. Our nth term is negative 1 to the n over 2. And if you take a look at some of these terms, when n is 1, for example, you get negative 1/2. When it's 2, you get 1/2. When it's 3, you get negative 1/2. Then positive 1/2, etc. There is no limit here. And because there is no limit, that diverges. Okay? There is no limit. If you had that series to add up those terms, that series would also diverge because that nth term is not going to 0. Number 3. Nth term, 1 over 10 to the n. As n goes to infinity, that denominator will increase without bound. That fraction will rapidly approach 0. This will converge to 0. If you had a series of those terms, the series would also converge. Yes?
You don't take the limit of that?
Say that again.
You don't take the limit of it?
Yes, you can. Yeah, and you'll end up with this going to infinity, therefore the limit is 0.
Oh, okay.
Yeah. All right, there's the sequences. We all set on those? Okay, number 4. In number 4, you're going to have to find the sum of these series. There are 2 kinds of series for which we can find the sum. One is geometric and the other is telescoping. The first one is geometric. Okay? It's geometric because each term is multiplied by the same constant r to get the next term. That r is negative 1/2. It's called the ratio or common ratio. 1 times a negative 1/2 is a negative 1/2. Negative 1/2 times a negative 1/2 is a positive 1/4. Positive 1/4 times a negative 1/2 is a negative 1/8. That's our ratio. As long as that ratio has an absolute value less than 1, the series converges. Not only do we know that it converges, but we know its sum. The sum is equal to a over 1 minus r. In this case, a, 1, r is negative 1/2. We get 1 over 1 minus a half, 1 plus a half, 3 halves, which is equal to 2/3. Okay? That series will converge to 2/3. Okay? If you have a question, let me know. Okay? Number 5. We have a series, n equals 0 to infinity. 0.2 to the n. Let's write out a few terms. When n is 0, we get 1 plus. When n is 1, we get 0.2. When it's 2, we get 0.04. When it's 3, it would be 0.008, etc. The series is geometric. You multiply each term by the same r, 0.2, to get to the next term. Since the r is 0.2, has an absolute value less than 1, this series converges. What's its sum? The sum is a over 1 minus r. Here's a, 1 minus r. You get 1 over 0.8. You're not going to find that on the test. On the test, you're going to find, this is 5/4, I guess, as an answer. 5/4 is an answer. If you were to multiply numerator and denominator by 10, you get 10/8, which is equal to 5/4. I'm pretty sure that's what I would have, that fraction 5/4 as the answer, okay? As opposed to 1.25, all right? Everybody all set on that one? Wow. Okay, fine. Number 6. 6 is not geometric. Let's write out a couple terms. Let's see what we got here. But you should realize this is telescoping, okay? This is in the form for a telescoping sum. If you write out a couple terms, you're going to end up with n equals 0. Let's see. So there's a 1 times 3, you get 1/3. When it's 1, you're going to get 2 times 4, 1/8. When it's 2, you're going to get 3 times 5, a 15th. So it's clearly not geometric. You're not multiplying each term by the same thing to get to the next. But it is telescoping. And the way to handle these telescoping sums is to do the following. Okay, what we're going to do is use partial fractions to split that expression up. So, 1 over n plus 1, n plus 3. A over n plus 1, a b over n plus 3. Let's solve for a. You solve for a by multiplying by n plus 1. Let n equal -1. You get -1 plus 3 is 2. A is 1/2. Let's solve for b. Multiply by n plus 3. Let n equal -3. b is -1/2. Therefore, we can write that sum this way. (1/2) over the n plus 1 minus 1/2 over the n plus 3. And at this point, it's probably worth your while just to take the 1/2 all the way out front to give you this. You don't have to do this, but it's probably easier. Now, let's see what happens if we generate a few of these terms. N equals 0. We get 1 over 1. We get 1 minus 1/3. And please note that 1 minus 1/3 is 2/3, but times a half gives us the 1/3 that we had from before. Plus, now when n is 1, we're going to get a 1/2 minus 1/4. That's equal to 1/4 times the 1/2 will give us the 1/8 that we had from before. We're going to generate the same terms, but they're in a slightly different form. Okay. When it's 2, we're going to get 1/3 minus 1/5, etc. And we're going to keep on going here. Now, if we let this go to k and took the limit as k goes to infinity, we get our last two terms in terms of k. We don't even have to do that, though. We realize that those last two, well, what happens here? 1/3s cancel, 1/4s cancel, this 1/5 will cancel. Everything in the beginning cancels except these two terms. And at the very end, everything will cancel except the last two terms. But those two terms have a k or whatever it is in the denominator. They will go to 0. They don't even matter. The only thing that matters here are these two terms that stay in the beginning. And you could have predicted that you had two terms in the beginning because the difference in n plus 3 and n plus 1 is 2. That difference tells you how many terms you're going to have in the beginning. 2 terms. And those are the only two terms that matter as far as the sum is concerned. So you have 1 plus 1/2 is 3/2. It's equal to 3/4. The sum of that infinite series is 3/4. Okay? It's 3/4. Any questions on that?
Well, how did we do the?
Say that again.
No, right, no, I got it.
Okay.
Continue.
I have a question.
Yeah, go ahead.
If B wasn't a negative, it would be plus those two fractions, right?
If B was not a negative,
Yeah, if it was a positive.
we'd have a problem. If we had a positive there, these things wouldn't be canceling out, and we would have a big problem. We couldn't do the
Oh,
problem.
so it's always a negative?
Guaranteed. Guaranteed.
I didn't get it.
Good question. Because yeah, that's guaranteed. Okay?
Disgusting.
You guys all right? Or is it? Yeah, all right. Let's keep on going. What's next? State whether the series converges or diverges. All right, let's take a look at this. Now, I'm not asking for any proofs here. Here's how I think you should do these series. First of all, this first one is a P series. P is equal to 1. In order for a P series to converge, P has to be greater than 1. So this will diverge. Now, that's using a P series. We could use that little shortcut that I gave you. If the difference in which is basically based on the P series, if the difference in degrees, denominator minus numerator, is greater than 1, it will converge. Otherwise, it diverges. This difference in degrees is only 1, not good enough. This diverges. This is called a harmonic series. You could prove that it diverges with an integral test. We probably did. I think we probably did. Okay? That thing will go to infinity with an integral test, proving it diverges. All right, that's 7. 8. Is 1 over n to the 4th plus 1. Again, a difference in degrees is what you're going to use. You got an n to the 4th. You have a constant up in the numerator. The difference in degrees is 4, more than enough to cause this series to converge. Now, if you actually had to prove it, what you would do is do a limit comparison test with 1 over n to the 4th. And 1 over n to the 4th is a P series, which clearly converges. P is 4, greater than 1. Therefore, a limit comparison test would show that this one also converges. Okay? But you don't even have to do that. Difference in degrees is sufficient. Number 9. You have n equals 0 to infinity, 4 to the n exponential function, an n factorial. Now, what you're going to use here is that little shortcut that I gave you about rates of relative increase. Numerator is an exponential function. It increases pretty fast. It's going to infinity for sure. Okay? But the denominator is a factorial. That goes to infinity as well, and it gets there faster. Since the numerator is increasing faster than the denominator, since the numerator is not increasing as fast as the denominator, since the denominator is increasing faster than the numerator, that will go to 0 quickly enough to cause it to converge. Now, if you have doubts, the test to use to prove it would be a ratio test. Okay? And I'm going to do it. I'm going to do a ratio test. I'll do one ratio test. Let's do it. It's pretty simple. Let's do the ratio test. N plus first term over the nth term. We're going to find that limit. Okay. If that limit is greater than 1, the series diverges. If that limit is less than 1, the series converges. If that limit is equal to 1, the test fails. So let's find out what we got here. We've taken the limit. N goes to infinity. We have a 4 to the n plus 1. We have an n factorial that comes up to the numerator. We have a 4 to the n, and we have an n plus 1 factorial. We don't need the absolute values. We don't have any negative numbers here, no alternating series. 4 to the n plus 1 over 4 to the n, subtract the exponents to get a 4. n factorial over n plus 1 factorial is n plus 1. N plus 1 factorial is n plus 1 times n factorial. 7 factorial is 7 times 6 factorial. Okay? This limit as n goes to infinity is 0. That's less than 1. Therefore, the series converges, which is what we said. Any questions on that? I'm not going to ask you to prove it, but that would be a proof. Okay? Number 10. Sum. We got square root of n plus 5. What about this series? What do you think? No, it's not. If it were 1 over that, it would be a p-series, kind of a p-series. You could compare it to a p-series. It's not a p-series. Root test is not going to be good here because root test you use when you've got an n hanging out on the outside. You don't. You have a to the 1/2 on the outside. What about this series? Converge or diverge? Someone?
Diverge?
It diverges. It diverges. Why? This term, is this term going to 0 at all? No, it's increasing. It's not going to go to 0 at all. If the nth term does not go to 0, that series has no hope of converging. None. Okay? This term is going to infinity. You're adding up numbers that are getting greater and greater and greater. And guess what? The sum of those numbers is getting greater and greater and greater and going to infinity. This definitely diverges. The nth term is not going to 0. 11. Bless you. N equals 1. Bless you.
Sorry.
It's okay. 5 to the n over n to the 5th. 5 to the n is exponential. It's increasing pretty fast. We saw it back here, though. It wasn't increasing faster than those factorials. But the denominator here is an n to the 5th. That's a polynomial function. It's going to infinity as well. But guess what? The exponential functions are increasing faster than that polynomial function. This term is not going to go to 0. This series will not converge. This series will diverge. Because that numerator is increasing faster than the denominator. And because of that, these terms are not going to 0. Okay? How would you prove it? A ratio test would be the proof. Okay? You don't need to do a proof, in my opinion, as long as you realize the exponential functions increase faster. If you had the reciprocal of this, that would converge. Okay? Because the denominator would be increasing faster than the numerator in that case. Number 12. What the heck is that? Oh, 3/2. What about this series? Converge or diverge? Converge. And the reason it converges is the difference in degrees is 1.5, good enough to converge, as long as that difference is greater than 1. Okay. If you had to prove it, limit comparison test with 1 over n to the 3/2, a known converging p-series would do the trick.
It has to be less than 1?
The difference in degrees has to be greater than 1 for it to converge, and this difference in degrees is 1.5.
Or 1?
Yep. 13. N equals 1 to infinity. N factorial over 5 to the n. Numerator is going to infinity, denominator is going to infinity. Factorials increase faster than exponential functions, therefore the numerator is increasing faster. Therefore, this will diverge. Okay? How you guys doing, all right? That did not sound sincere. I gotta tell you. Okay. 14. Say whether the alternating series converges conditionally, converges absolutely, or diverges. Oh my goodness. us. All right, let's take a look. Number 14. Here's our alternating series. In my opinion, the way to go is this. Let's look at the positive series first. Let's see what happens with the positive series. In other words, ignore the negative one. Let's look at this positive series. What can you tell me about that positive series? That is going to zero. Is it going to zero fast enough to cause the series to converge?
Yeah.
Yes, it is. Difference in degrees is 2. Good enough. This will converge. This positive series converges. What does that tell you about the alternating series? Converges absolutely. Or is absolutely convergent. Either way. Okay? Converges absolutely. In other words, it does not have to be an alternating series for that series to converge. The positive series converges already. Okay? Converges whether it's alternating or not. Converges absolutely. 15. Again, let's look at its positive series. What about this positive series? Does it converge or diverge? What does it do? Diverges. Difference in degrees is 1/2. Not good enough. This will diverge. P series where P is equal to 1/2. You could rewrite it this way. Not good enough.
Why do you ignore
The negative 1 part?
no, the
Because
exponent end?
this here, because this whole negative 1, that negative 1 to the end causes it to alternate. Positive 1, negative 1, positive 1, negative 1. It's what makes this alternating. But in order to determine what kind of convergence or divergence we actually have, you ignore that and look at its positive series first. And that means ignore that. Let's look at its positive series. Now up here when we did that, the positive series converged. That meant we were done with the problem. The alternating series converges absolutely. But this one, the positive series diverged. Here's what we found out so far. We know this, that this alternating series does not converge absolutely. That's what we know right now. But there's 2 possibilities left. It converges conditionally, okay, or it diverges. And what you're going to do to determine which one of those is use the alternating series test. Okay? So that's what we're going to do right now. We're going to use the alternating series test. The alternating series test, there's 2 conditions. One condition is, what is the limit as n goes to infinity of this positive term? What is that limit as n goes to infinity? It is 0. That's one part of the test. It passes that test, part of the test. Okay, those terms are going to 0. If it failed this, we're done. Series diverges. Okay, but it passed that. The next part of the test, are the terms decreasing? In other words, start with n equal 1. You get 1 over 1. Is that greater than or equal to 1 over the square root of 2? Is that greater than or is this 1 greater than or equal to 1 over the square root of 2? Bless you. Is everybody allergic to these things? Is that what we got here? 1 over the square root of 3, 1 over the square root of 4, which is 1/2. Are these terms decreasing? And the answer is yes, they are. Okay, they are decreasing. Therefore, our original alternating series, what is the answer to the question? Does it converge absolutely, converge conditionally, or diverge?
Converge condition.
Converge conditionally is correct. Okay? Converges conditionally. All righty? We all set on that? That's what you got to do there. 16. N equals 1 to infinity. You got negative 1 to the n times n. Let's look at its positive series. Positive series diverges. That nth term is not even going to 0. And you know what? You can stop right here. That nth term is not only not going to it's not going to 0. That's all you need to cause that series to diverge. You're done. Okay? As long as that nth term doesn't go to 0, the series will diverge. So we had absolute convergence on the first, conditional convergence on the second, and divergence on the third. Now, on the test on Monday, guess what? I'm going to give you 3 alternating series. And guess what else? You probably have one of each, you know what I mean? So, just saying.
The second one is
Conditional convergence.
Yeah.
What's that?
I got to do that, sir.
All right. Oh, okay. All right, good. All right, 17 and 18. Let's take a look. We got radius of convergence for each power series. All right, let's take a look. All right. This is a power series we looked at. This is a power series we have in the lab. This is a power series for e to the x. Okay? This is equal to e to the x, as a matter of fact. And we want to determine for which x's the series converges. I don't know if we did it or not, but let's do it. Okay? Now, just think about this, though. What you're trying to do is determine for which values of x the series converges. That means x is going to be some number. Okay? We want to find out what number x is, or could be, and have the series converge. Well, no matter what you put in for x, that numerator is going to be an exponential function. 2 to the n, 3 to the n, 10 to the n, 100 to the n, 50 to the n, negative 2 to the n, negative 3 to the n, 1/2 to the n, whatever the heck it is. It's an exponential function. That denominator is factorial. I don't care what you put in for x. Factorials are going to increase faster than exponential functions. This thing is going to go to 0 fast enough to cause the series to converge for every real number x. The radius of convergence for this power series is infinite. Okay? Infinite. It's just converging for all x. Let's prove it. Let's use the ratio test. No, let's do it. Let's take the limit as n goes to infinity. We'll take the n plus first term over the nth term. And we want to find out for which x's this is less than 1. Because it's for those x's the ratio test says it converges. Take the limit as n goes to infinity. X to the n plus 1 times n factorial. Bring this up. Bring this guy down. X to the n plus 1 factorial. Okay. Okay. Everybody else set with that? How we doing? All right. Okay. Here we go. Now we're going to simplify. We have x to the n plus 1 over x to the n. That's an x. We have an n factorial over n plus 1 factorial. That's an n plus 1. We're going to take n going to infinity. I don't care what value of x you put up there for x. As long as that denominator is going to go to infinity, this is equal to 0. That 0 is less than 1 for all x's. Okay? The radius of convergence is infinite. Okay? The interval of convergence, which we don't really do because I'm going to ask you for a radius of convergence. An interval of convergence here would be this. All real numbers, in other words. That converges for every real number. Okay? 18. Yes. Go.
So if it's less than 1, then that means it's infinity. What if it's greater than 1?
What if, what now?
Let's say it was like 2
What was 2?
instead of 0.
Oh, okay. If this came out to 2, the limit as n goes to infinity came out to be 2, then it diverges, and the radius of convergence would be 0 in that case. See, the radius of convergence is either 0, in other words, you're adding up an infinite number of x's that are all zeros, or the radius of convergence is some real number, and that's going to happen in the next one, okay? Some real number, or the radius of convergence is infinite, and that's what happens here. Okay, yes?
What if there was n minus 1?
It would still be okay. It would still be a 0 and less than 1. Yes. If that's n minus 1 here, yes. Because that's still going to increase without bound.
Yeah, but so was x, right?
No, x, it's somewhat strange. But believe it or not, in this context, it's really the x that's the constant and the n that's a variable. The x is fixed. It's some real number. The n is what's going to infinity. Yeah, it's kind of weird. But that's what it is. Let's look at this next one. The next one's kind of weird too, because I didn't do many with these. But I'm going to tell you. This is a power series centered at 5. We want the radius of convergence. Well, I'll tell you what. You can ignore this thing centered at 5, and my recommendation to you is to look at this series instead. Whatever the radius of convergence is for this series will be the radius of convergence for this series. All this is a shift, okay? It's a shift. So, let's examine this series. We want to find the values of x for which this series converges. Let's use the ratio test. Take the limit as n goes to infinity. X to the n plus 1. 5 to the n plus 1, x to the n, 5 to the n. We want to find the x's that cause that ratio to be less than 1. Okay, we have x to the n plus 1. We have a 5 to the n. We have an x to the n, and we have a 5 to the n plus 1. We have an x over 5. There are no n's in there. They all went away. As n goes to infinity, this limit is the x over 5. There's no n's. So we end up with the absolute value of x over 5 is less than 1. And now what you can do is multiply both sides by 5 to get the absolute value of x is less than 5. Okay? This is R. That's a radius of convergence. Okay? That's what I'm asking you for, the radius of convergence. Done with that problem. Radius of convergence is 5. Now, if I had asked for an interval of convergence, then you'd have this. Okay? And you'd have to test the endpoints to see if any of these endpoints cause it to converge. You test at negative 5. Okay? Put a negative 5 in there, and you're going to get a negative 1. Well, if you add up an infinite number of negative 1s, that's not converging. Okay? If you put a 5 in there, you get 5 to the n over 5 to the n, you get an infinite sum of 1s. That doesn't converge either. It doesn't converge at either of those endpoints. This would be the interval of convergence for this series. Now, to get the interval of convergence for the original series, you'd replace the x with x minus 5. You'd go back there. And you'd do this. And add 5 to everything. That would be your interval of convergence. All I've done is shifted it 5 units over. I shifted it 5 units in the beginning, and I shifted it back in the end. Okay? The interval of convergence would be from 0 to 10. Please note, from 0 to 10 for x's, I'm still going to get the same range from negative 5 to 5. Okay, when x goes from 0 to 10. But I'm not going to ask you for the interval of convergence. I'm going to ask you for the radius of convergence, which is right here.
Professor, so it's just R equals 5 then?
Yes, that's the answer. R equals 5. How are we doing, all right? Couple more to go, and we'll be done. All right, go get Chinese food or whatever you want to eat. Ooh, the fort. You're going to eat snake and buffalo and bison and oak. And, I mean, not oak. Elk. What?
It's not game season.
Oh, it's not? I'm sorry. Ooh, I didn't realize that. So what do you have instead? Snake and... No, they're still hibernating.
Fried shrimp and the fried cheese.
fried cheese.
It's camembert. It's delicious.
Really?
Have you ever eaten there?
No.
You should go.
I'm not a meat eater. I haven't had a hamburger in about 20 years. So we don't eat, none of us, our family eats any meat. What's that? Oh, well, chicken I eat, and turkey. For some reason, I make a distinction there. I don't know why. I'm inconsistent. What? I don't have veal. How can you eat veal? Baby lambs, for crying out
Just
loud.
don't think about it when you're eating it.
What?
Just don't think about it. Just think about how good it tastes.
I don't know. That's not right. That is not right. Veal is like, to me, the worst possible food because it's a lamb. I mean, how can you kill the little lamb and eat it? Oh my God, it sounds so primitive. But anyhow, but I eat chicken and turkey, so I'm inconsistent. I agree with it. I recognize that. But anyhow, yeah. So we don't eat at the fort ever because that's what they serve, though, right? Oh, shrimp I would have too.
Shrimp's good.
Yeah, shrimp.
What about the baby shrimp? Go back to that.
I guess I would, wouldn't I? It's not the same.
It's not the same.
No, it's not
You
the
don't care about the baby
same.
shrimp.
I don't care about the baby shrimp. They're not looking at me, and they're not little
They're
critters that
right,
I.
you.
Yeah, you're right. All right, 19 and 20. All right, use the Maclaurin series for sin x for the following. All right, sin x. What you got to remember, sin is an odd function. Therefore, you have this. And we're going to use the first two non-zero terms. There you go. First two non-zero terms. If I ask you for cosine on the test, cosine being the even function it is, it's going to be a 1 minus x squared over 2 factorial, or 2. Okay? That would be the first two terms. So I'm asking you for the two non-zero terms, approximate sine of 1/2.
What's under the record button? Is that an X?
What's that? Oh, I'm right over it. Okay.
All right.
Oh, that's all right. I thought I was doing something bad over here. I know Nick yells at me for covering up the microphone and stuff. But anyhow, that's 1/2 minus 1/2 cubed is 1/8. That's 1/48. So go to 48ths, I guess. Here, this is the worst part of the test, is right here with these fractions. Multiply by 24 over 24, you get 24 48ths. Minus 1, you get 23 48ths. I believe I have fractions in there. I think that's what I put, the fractions in there. That would be your approximation, 23 48ths. Okay? Now, what kind of error do we have? The error is less than or equal to the absolute value of the next term. What is the next term? The next term is 1/2 to the 5th over 5 factorial. So even this pretty basic approximation, two terms for Pete's sake, we got error that's less than 1 over 2 to the 5th, it's 1/32. 5 factorial is 120. We've got an error that's less than 32 times 120. We got that? 32 times 120?
3.84 times 10 to the third, so
Got it.
3840.
3840. That's the error. In other words, our approximation is within 1 over 3,840 of the actual value of sine of 1/2 a radian. If you were to do the sine of 1/2 a radian, here, let's try it. Let's just try it. All right. On your calculator, be in radians, do 1/2, do the sine of 1/2. And what do you got? What is it? No?
479.
Oh,
Radians, 0.42.
40.
42073549.
Okay, that's good enough. And our approximation of 23 48ths is equal to what? What's 23 48ths?
Sine 1/2 is
What is it?
0.4794.
479?
And 23/48 is 0.47916.
Wait.
I got a different answer for
Oh,
sine
he's got a different answer.
Mine is in radians.
Yeah, your 1/2 is in radians. You have to be a radian measure, and if you take the sine of 1/2 a radian, He says you get 0.479.
Well, mine is signed in radians. I know that for sure. Mine shows.
Radians, okay, so don't try again.
Yeah.
Oh, that's right. Problem is, you're taking the sine of 1 and dividing that by 2. So you gotta put that in plus.
He's just,
Sine of 0.5, just.
he's just checking.
Okay. Obviously, parentheses.
Yeah, next error is 1/3.
479,425. 479,425. And what's this one? 479?
166 repeating.
166 repeating. If you were to subtract one from the other, you're going to get 0, 0, 0, 3, no, 2, I don't know, 3 something or other, which is going to be less than this. In other words, all right. Now I need 1 over 3840. What is 1 over 3840? What is this approximately?
Like the difference of them. And then 1 divided by 3480.
3840. I'm not sure you said that right.
Yeah, they're pretty much.
Yeah, pretty much the same. That's it. We get
That's crazy.
pretty good approximation, but too crummy. And at 1/2, we're pretty far from 0, too. And we still get that good an approximation. It's just astounding. Well, we saw that the other day. What did we use? 5 terms, and we got 15, 16-digit accuracy, for Pete's sake. It's amazing. Okay, it's amazing stuff. Okay, that is your test. Now,
Supposed to do 2 of them?
what's that?
There's only a few.
Say that again.
No, it's the first 2 non-zero terms.
Yes.
You only do 1? What was it?
I did the first 2 non-zero terms, and that gave me this. That was my approximation.
It's not only 1 number? Oh, wait, oh.
I combined these. I'm not sure what you're asking me about, Danielle.
You said the first 2 non-zero terms.
Yeah,
so
here's the
what-
first 2 non-zero terms of sine, this and this.
Okay.
Okay, and then I put a half in here and a half in here. And we did that out, we got 23/48. That's our approximation. Yep. Okay. Questions?
Right? Download that.
Yes, you may. Yes, sir. Pardon? Okay, let's make sure we're okay here, though. Any questions, anybody? Bless you.
Bless you.
Anybody else?
Bless you.
Okay. We'll have the test on Monday.